Okay, so by the time that you're watching this video, you should already have a pretty basic understanding of carburetors and how they work. But what I'm going to do here today is kind of give you a real-life demonstration or example of what a carburetor actually does. So by this point in time, there's a couple of principles that you should understand, namely the Venturi effect. And the Venturi effect is that anytime you take a fluid or air and you run it through a pipe or a tube, and then you decrease the diameter of that tube, it increases the velocity or the speed of the air moving through that. The principles that carburetors work on is that right there, is the Venturi effect. So what happens is, as that air speed increases, it actually decreases the air pressure right behind any obstruction that you may find, which creates a vacuum and allows for any fluid, or liquid in this case, gasoline, to be drawn out. So what I've got here today is just a beaker that's filled with water, and I've just put some food coloring in it so that it's super easy to see. But this right here represents your carburetor. It represents the bowl of the carburetor. And obviously the blue water that I have represents gasoline. Right here, I just have a common household straw that we're going to put inside the beaker. And I know it's kind of hard to see on that screen, but maybe if I hold my hand right there, I don't know. But you can see the straw right here. So the straw is actually, it's what, it symbolizes the jets that are found inside the carburetor. And then this giant area right here is going to symbolize the tube or the intake of the carburetor. And then as we change the velocity of the air passing through this point or passing over the straw, it's actually going to draw gasoline, water, out of the bottom of this beaker. The way that we're going to change the flow of air is right here with the compressed air. Okay, so I just have an air nozzle on there, and I'll turn the air hose on in just a second. But what we can do is, as we angle this hose right here, it will change the velocity of the air coming out of the straw. And one thing that you'll see as we do this demonstration is that it pulls up the gasoline from the bottom and it atomizes it. And I'll change the angle of the air hose, which is the same thing as changing the velocity of the air traveling through there. Essentially the same as changing the throttle or adjusting the throttle mechanism on your engine. And that will change the amount of liquid or gasoline that we see coming out. And you'll see that that's atomized in a very, very fine spray, and you can see that that changes, and hopefully the blue food coloring lets us do that just a little bit better. So I'm going to demonstrate that. We'll see how that works, and then we'll talk about it again in just a second. Okay, so as I set this right here, and I put my air hose right here, I start like this, and then as I come down, it starts blowing that fine mist, and I can change the amount of atomized gasoline that comes out by the direction that I put my airflow. And notice as I pass a very limited amount of air over the top of it, a smaller amount of fuel comes out. But as I really increase that, or I extend it to full throttle, it's really drawing down the level inside that beaker at a very accelerated rate. Okay? So the reason, the physics principles behind that is as the air passes over here, where this is essentially acting as our Venturi. And we can change the angle of that air nozzle and bounce it up and down. And what that does is just changes that. It changes the velocity of the air passing over this point. So because of that, on the back side of the straw, we have a lower air pressure than we do down here, which is drawing this liquid or this gasoline up kind of in the vacuum process. And that's how we get that gas that's atomized. So it's kind of cool to do it this way. One thing that I really like to do is, especially when I have a class of students, I won't use blue food coloring, but you know, if this was a real life setting, I would ask the kids to, you know, if they understand this principle and they understand how carburetors work, to come stand right here. And so I would stand them actually right in front of this, like obviously back a little ways. So I'll stand them right in front of this, and then I'll run this principle, and you can see real quick the kids that understand it and the kids that don't, because the kids that actually understand what's going to happen and the you students that get the whole Venturi effect will move out of the way, because you know that there's going to be a fine mist of gasoline or water that comes up through that. So I'll show you that one more time, just kind of so you can see it. Make sure that we know what's going on there. There's our air pressure, our air velocity. As we change that air velocity, it changes the air pressure behind the straw or the jet, which actually ends up drawing the gasoline out of the beaker or out of the carburetor. So we start right there. There's our full throttle again. Okay. So that's how carburetors work. It's a very simple thing to kind of, once you get it figured out. But if that carburetor does not have adequate airflow to draw that fuel up through there, then it will not be able to get that atomized fuel into the engine. And the engine, as we know, will not start on raw fuel alone. So that atomization of the fuel has to occur. And that's all made possible through the Venturi effect, which is the changing of the the changing of the air velocity due to essentially a constriction in the tube that it goes through. I look forward to seeing your assignments and being able to gauge your understanding of the Venturi effect, and to make sure that you understand exactly how a carburetor works as far as air pressure and airflow goes. Good luck!